In this video, we will be reviewing the key area numbers under the Year 7 Maths syllabus. The main topic covered under this area includes basic operators and symbols such as addition, subtraction, division, multiplication, greater than and less than symbols, prime numbers and composite numbers, roots, fractions, decimals, chance and probability, percentages, and ratios. The first subtopic under numbers is addition, subtraction, division, and multiplication. These are operators and symbols that you're very familiar with, so we might not spend much time on them. But I do want to touch on two symbols, greater than and less than, which can be confusing to some students. The easiest way to remember what this symbol means is to look at the shape of the symbol. If you look at the pointier, narrower end of the symbol, always remember that the pointier, narrower end points to the smaller number, and the wider, open end points to the larger number. So the wider end points to the larger number, and the pointier, narrower end points to the smaller number. Let's look at this particular example. As you can see that the pointier end always points to the smaller number, in this case 1, and the wider end points to the larger number. That's just a small tip in case you get confused with the symbol. A common question that you'll find in your exams is where you will be asked to divide large numbers by smaller numbers. So you'll be asked a question, for example, is 1266 divisible by 3? So there are two ways to approach this type of question. You can either divide the number, do the actual division of it manually, or there are some tips that we can tell you that you can use to quickly work out whether a number is divisible by another number. Let's start from the top. You may already know that all even numbers are divisible by 2. So if you are asked the question, is this number divisible by 2? If you look at 1266, it ends with an even number. So you know that it is very easily divisible by 2. If it ends with an odd number, you know that it won't be able to be divided by 2. That's the easier bit, I think. When the question comes to, is a number divisible by 3? Can you divide a number by 3? There's another trick that you can use. So the rule is, if you take the individual digits of that number and add them up until they reach a single number, if they total 3, 6, or 9, they are then divisible by 3. So let's look at these examples. 345. So what are we going to do? We take the individual digits, 3, 4, and 5. We add them up. 3 plus 4 plus 5 gives you 12. We keep adding them again until we get a single number. So 1 plus 2 in this instance gives you 3. So yes, the individual digits of 345 add up to 3. So yes, it's a number that can be divided by 3. Let's look at the second example, 245. 2 plus 4 plus 5 gives you 11. 1 plus 1 gives you 2. So no, it doesn't add up to 3, 6, or 9. So 245 is not divisible by 3. Let's look at the third example, 1266. 1 plus 2 plus 6 plus 6 is equal to 15. 1 plus 5 is equal to 6. So yes, the individual digits add up to 6. In this case, 1266 is divisible by 3. A trick you can use to see if a larger number can be divided by 4 is to look at the last two digits as a whole number and see if you can divide the last two digits by 4. So if you look at the example here, 322, is 22 divisible by 4? No. So you know that 322 can't be divided by 4. Let's look at 524. The last two digits are 24. Is 24 divisible by 4? Yes, 24 divided by 4 is 6. So yes, you can divide 24 by 4. So 524 is divisible by 4. Let's look at this very large number, 4,687,512. Can this number be divided by 4? If you were to divide this using the traditional method, this is going to take you a bit of time. So the easiest thing would be to apply this technique. Check the last two digits. 12. Can 12 be divided by 4? Yes. When 12 is divided by 4, you get 3. So 4,687,512 can be divided by 4. If you are asked to identify whether a large number can be divided by 5, the tip is to see whether the last digit is a 0 or a 5. So if the last digit is a 0 or a 5, you can confidently say that that number can be divided by 5. So 360, the last digit is a 0, that's a tick. So 360, yes, can be divided by 5. 46,554, the last digit is a 4. It's not a 0, it's not a 5, so no, you can't divide it by 5. 5,468,715, the last digit is a 5, so yes, it ticks the box, it can be divided by 5. While you may be very familiar with solving questions involving addition, subtraction, multiplication, and division, it's always important to remember the order in which you would tackle a more complex question. Let's look at this example. 6 plus 5 multiplied by 3. How would you go about solving this question? Would you multiply the 5 by 3 first and then add the 6? Or would you add 6 and 5 and then multiply that answer by 3? Let's look at the two ways in which this question can be approached. So one alternative would be to multiply the 5 by 3, giving you 15. You add the 6 to the 15, giving you an answer of 21. The other alternative is to add the 6 and the 5 together, giving you a total of 11. And then you multiply the 11 by 3, giving you an answer of 33. So which one is the right response? Is the correct answer 21 or is it 33? To help us make this determination, we use this rule called BODMAS. BODMAS is a made-up word that helps you remember the order in which to approach these questions. So the first thing you would always do is tackle brackets. If there are any brackets in the question, that's the first thing you would do, is to tackle the brackets. The second thing you would do is to tackle powers and roots. The third thing, division. The fourth thing, multiplication, and then followed by addition and subtraction. So if you look at this example, you have both addition and multiplication. What would you do first? As per our rule of BODMAS, multiplication comes before addition. So you would multiply 5 by 3, giving you 15, and then add 6 to that total, giving you a final answer of 21. So in this example, 21 is the correct answer, and if you had approached the question by adding first and then multiplying, you would have got the answer 33, which is wrong. There is a small exception to the BODMAS rule though, and that is that addition and subtraction can be interchanged. While it's very important to follow the order through from brackets to multiplication, it doesn't matter if you do the addition before the subtraction or the subtraction before the addition. That can be interchanged. So let's look at an example. 6 minus 5 plus 3. If you deduct the 5 from the 6, it gives you 1, plus 3 gives you 4. Or, alternatively, you can take the negative 5 and add it to the 3, giving you a negative 2, and then deduct the 2 from the 6 to give you a 4. So that's just it's just a little thing for you to remember, is that addition and subtraction can be interchanged, and you don't have to do the addition first followed by the subtraction. You can do subtraction followed by addition, and it'll give you the same answer. Let's look at a few more questions where we can apply the rule of BODMAS to solve more complex questions. So in this first example, you have brackets and you have multiplication. If you look at BODMAS, the very first thing that you would do is tackle the brackets. Multiplication comes further down the line. So brackets first, then followed by multiplication. So what's happening within the brackets? In this circumstance, we have to deduct 2 from 8. So that's what we would do first to tackle the brackets. 2 subtracted from 8 will give you 6. Then the multiplication, 6 times 3 gives you an answer of 18. Let's look at the second example. This example involves addition, subtraction, and 2 to the power of 2. So powers as well. So let's look at our rule. So powers or orders is the first thing that you would do, followed by addition and subtraction, which we know now can be interchanged. So 2 to the power of 2 gives you 4. 8 minus 4 gives you 4, plus 3 gives you an answer of 7. Let's look at the third example. You have subtraction and division involved in this example. When we look at our rule BODMAS, we see that division comes before subtraction. So 4 divided by 2 is 2, and subtracting the 2 from 9 gives you an answer of 7. In the next example, we have addition and multiplication. So looking at the rule of BODMAS, we know that multiplication comes before addition. So 6 multiplied by 3 gives you a total of 18, and you would add 3 plus 4 to 18 to give you a total of 25. Let's look at the last example, which involves brackets. It involves division, it involves addition, and it involves multiplication. So let's look at BODMAS. What comes first? Always tackle brackets first. So let's tackle the brackets. 1 deducted from 3 gives you 2. We've tackled the brackets. Now we have division, addition and multiplication. Division, multiplication, addition. So division first. So 12 divided by 2 gives you 6. And then we address the multiplication. 2 times 3 is 6 as well, giving you a total, once you add the 6 and the 6, of 12. So in this example, we had brackets, we had division, addition, and multiplication. As per the rule of BODMAS, we would tackle brackets first, we then tackled division, we then tackled multiplication, followed by addition finally, to give us an answer of 12. Now let's look at prime numbers and composite numbers. What is a prime number and what is a composite number? A prime number is a number which can only be divided by 1 and itself. So you won't be able to divide a prime number by any other number other than 1 and itself. A composite number, on the other hand, is any number that isn't a prime number. That's a composite number. So let's start from the beginning and look at a few examples. So one rule that you have to remember is that 0 and 1 are neither prime nor composite numbers. Let's start with the next number in the sequence, 2. So 2 can be divided by 1 and itself, but can it be divided by any other number? No, it can't. So 2 is a prime number. Another rule that you need to remember is that 2 is the only even prime number. We know that all even numbers can be divided by 2, which then makes all other even numbers not prime numbers. So all other even numbers except for 2 are, in fact, composite numbers. Let's go along. 3. We know that 3 can be divided by 1 and 3 and no other number. So 3 is definitely a prime number. What about 4? 4 can be divided by 1 and 4, yes, but it can also be divided by 2 because it's an even number. So 4 is a composite number. What about 5? Can 5 be divided by anything other than 1 and 5? No, it can't. So 5 is a prime number. What about 6? 6 we know is an even number, which means it can be divided by 2, so it's definitely a composite number. 7? 7 is a prime number because it can't be divided by anything other than 1 or 7. So it's definitely a prime number. We know now that all even numbers are composite numbers, so 8 definitely is a composite number. What about 9? Can you divide 9 by anything other than 1 and 9? Yes, 9 can be divided by 3. So 9 is a composite number. What about 10? 10 we know is an even number. We know that 2 is the only even prime number, so 10 is a composite number. What about 11? Can we divide 11 by anything other than 1 or 11? No. So we know that 11 is a prime number. 12 is an even number, so by default it's a composite number. 13. 13. What about 13? 13 can only be divided by 1 and by 13, so 13 is definitely a prime number. What about 14? 14 is an even number, so by default 14 is a composite number. What about 15? 15, we know, can be divided by 5 because it ends with a 5. It can also be divided by 3 because when you add the first two digits of 1 and 5 together, you get 6. So we know the rule that any number that adds up to a 3, a 6, or a 9 can be divided by 3. So we know that 15 is not a prime number, it's a composite number. What about 16? Even number? Definitely a composite number. What about 17? Can you divide 17 by anything other than 1 or 17? No, you can't. So 17 is definitely a prime number. What about 18? 18 is easy. It's an even number. We know that 2 is the only even prime number, so 18 is automatically a composite number. What about 19? Can you divide 19 by anything other than 1 or 19? Can you divide it by 3, 4, 5, 6? No. So 19 is definitely a prime number. What about 20? We know that 20 can be divided by 2. It's definitely an even number. So by default, 20 is a composite number. So on, you can deduce what a prime number and a composite number is. In our question section, we'll be tackling some additional questions about identifying a composite number from a group of prime and composite numbers, or a prime number from a group of prime and composite numbers. Now let's look at squares and square roots. What is a square? A square is if you take a number and you multiply it by the same number, that gives you the square value of that number. It can also be written as 1 to the power of 2, or 2 to the power of 2, or 3 to the power of 2. So pretty much any number to the power of 2 is its square. So what does that actually mean? So if you have a number 5 to the power of 2, or 5 squared, and you're asked to calculate the value for that, what that means is the number 5 multiplied by the number 5 for a second time. So that gives you a value of 25. So the square of 5 is 25. Similarly, the square of 9 is 9 multiplied by 9, giving you a value of 81. It's pretty easy to calculate the square because you know square is any number to the power of 2, which means any number multiplied by that same number, and you can easily calculate the value. There is some merit, and it's worthwhile if you can actually learn what the square of a number is from 1 to 10. If you can have this at your fingertips, it's easier to solve some questions. While it's easy to calculate the square of a number, you're told, okay, give me the answer for the square of 10. So you know 10 to the power of 2, or 10 squared, is 10 times 10, and you can easily multiply that to get 100. The issue is when you are asked to calculate the square root. So we know what a square is. What is a square root? So let's remind ourselves of what a square is. So what is the square of 4? 4 squared is 16. But the second part of this is to learn what a square root is. Square root of 16 is 4. So if you are given a number, like 49 for example, and asked for the square root of that number, you will need to know that the square root is that base number that you multiplied by itself to get 49. So in this case, 7 is the square root. The symbol used to signify a square root is this. So if you have a number, 1 for example is an easy one because you know the square root of 1 is 1. You multiply 1 by 1 to give you 1. What is the square root of 4? What number did you multiply twice to get 4? And that number is 2. You know that you multiplied 2 by 2 to get your square of 4. So you know that the square root is 2. What is the square root of 36? Or what number did you multiply twice its value to give you 36? So there are two ways of doing this. You can easily go, okay, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and keep on multiplying until you reach 6 times 6, which is 36. Or if you know your squares and square roots from 1 is to 10, then it's easy for you. If you already know that 6 times 6 is 36, you already know that, and to answer a question where they've asked you for the square root of 36 will be very simple. Or if they ask you, what is the square root of 81? What is the square root of 81? How would you respond to that? If you already know that 9 times 9 is 81, you can answer that question in a matter of seconds. If you didn't know that 9 times 9 is 81, you would need to start multiplying many numbers before you reach 9 to actually figure out what is the square root of 81. So you can always do that. I'm not saying that you can't, but time is of the essence when you're at an exam. So if you can know the squares from 1 to 10, it'll make your life a little easier. Square root and square questions are also very common when you involve shapes and calculating areas. So, for example, we'll cover this in a bit more detail under a separate topic, but you will know that the area of a square is the multiplication of its width by its length, and you know that all sides of a square are the same, so the area of a square is the multiplication of the same value. So if we say that this square has a length and a width of 4 centimeters, so 4 times 4 centimeters will give you an area of 16 cubic centimeters. So you can see that you're using the squaring principle to calculate the area of a square. Alternatively, they can provide you the area of the square. So they've said in this circumstance that the area of this square is 64 cubic centimeters. So let's assume that the length of this square is x. So x times x is 64 cubic centimeters. What is x? Here you're being asked to calculate the square root of 64 cubic centimeters. So if you already know that 8 times 8 is 64, you know that the length x is equal to 8 centimeters. It's very straightforward. So that is the value in actually knowing your squares from 1 to 10. Following on from looking at squares and square roots, we're now going to look at cubes and cube roots. So a square we know is the same number multiplied twice, or a number to the power of 2. A cube, on the other hand, is the next step from a square. It's the same number multiplied 3 times, or a number to the power of 3. So the cube of 1 is 1 multiplied 3 times, which is 1. The cube of 4 is 4 multiplied by itself 3 times to give you 64. 4 times 4 times 4 is 64. Similar to square roots, a cube root is the base number that you would use to multiply to get a value. So if you have a question that asks you for the cube root of 27, you need to figure out the base number that you multiplied 3 times to get the value of 27. So in this example, 3 times 3 times 3 gives you 27. So the cube root of 27 is 3. The symbol used to signify a cube root is almost identical to the symbol used to signify a square root, except for the addition of this number 3 on the side. So if you see the symbol used to signify a square root with the number 3 on the side, it means that it's asking you to find out the cube root of that particular number. So what is the cube root of 8, for example? 2 multiplied by 2 multiplied by 2 gives you 8. So the cube root of 8 is 2. We looked at squares and the area of squares, which is where the principle of squaring came to be. Similarly, we look at the shape cube. You know, similar to a square, all the sides of a cube are equal to each other. And to calculate the area of a cube, you need to multiply the length by the width and the height. So, for example, if you knew that the length of a cube was 2 centimeters, to calculate the area of the cube, you would multiply 2 by 2 by 2. So, 2 to the power of 3 or 2 cubed to give you the area of 8 cubic centimeters, because the length, the width and the height are all equal to each other and they're all 2 centimeters in that example. The other way they can use a cube shape and ask you to calculate the cube root is by telling you that the area of a cube is, for example, 64 centimeters cubed. So, or 64 cubic centimeters. So, what is the length of one side of a cube? So you can say the length of the side of the cube is x. We know that to calculate the area of a cube, you need to multiply x by x by x. So the length, width and the height which are all equal to each other. So x cubed is equal to 64 cubic centimeters. So what is the square root of 64 cubic centimeters? We know that the square root of 64 cubic centimeters is 4. So we know that the side or the length of a side of the cube is, in this particular example, 4 centimeters. While the advice we provided to you was to learn the square roots from 1 to 10, we would probably give you the same advice to say it would be useful to learn the cube values from 1 till 4 at the very least. It allows you to solve problems much quickly when you are faced with them at the exam, when time is obviously of the essence. If not, you always have the opportunity to quickly multiply the numbers from starting from 1 up until you reach the value that you are looking for to calculate the cube root. But if you already know that the cube root of 64 is 4, it saves you the trouble of multiplying 1 3 times and 2 3 times and 3 3 times and then 4 3 times to give you 64. We'll look at more examples in our question samples that relate to this principle of cubes and cube roots.